All right, so we're looking at triangle congruence with ASA, AAS, and HL. So first we're going to talk about ASA. ASA is the abbreviation for angle, side, angle. So yesterday we talked about having an included angle. Today we're going to talk about an included side. So for this congruency, we need two angles and then the included side. So if I look at this diagram, we have angle A and angle C. And then when we say the included side, that means the side between those two angles, so side AC. And the same thing's true about the second triangle because it's marked congruent. The included side. So it's the side that's between the two angles that you know. So looking at this, we have two triangles with information marked on them. The first thing is angle A is marked congruent to angle D. So we know that because they have their little arc marks at A and at D. And then we have marked that side AB is congruent to side DE. And then we also have that angle B is congruent to angle E. So since that is my included side, the side between the two angles that we know are congruent, then the two triangles must therefore be congruent. So triangle ABC is congruent to triangle DEF. So we're going to work through some proofs with angle, side, angle. Remember, no two proofs are exactly the same. And sometimes you can solve a proof differently than somebody beside you and you can both be correct. So when we start out with our proofs, we're given the SQ bisects angle RQT and angle RST. So we're starting off our proof with the statement that was given to us. The reason that we can justify that is because it was given. For line number 2, we're told that angle RQS is congruent to angle TQS. That would be this angle and this angle. So how do we know that these two angles are congruent to each other? So we know they're congruent to each other because we were told in our given information that SQ, this segment here, bisects this big angle here. If it's bisecting it, it's breaking it up into two equal pieces. So by the definition of bisect, those two angles must be congruent. And then similarly for statement number 3, they're telling us that angle RSQ and angle TSQ are congruent. We know those two are congruent because, again, SQ is bisecting angle RST, so this angle has to be congruent to this angle. Again, by the definition of bisect. Statement number 4, we were told that QS is congruent to QS. Remember we talked about yesterday, anything is congruent to itself. So QS is congruent to QS. Remember we talked about the mirror, the reflexive property is what lets us say that QS is congruent to QS. So you can always prove something congruent to itself by the reflexive property. And now we've proven that we have an angle and another angle. And then important part here, the side we know has to be between those two angles, and QS is between angle Q and angle S. So therefore we've shown that these are congruent by angle, side, angle. And again, it's angle, side, angle because the side we know is included between the two angles that we know information about. Moving to the next question. This question, we're given another diagram and we're given that line segment JK is parallel to line segment LM. And line segment JL is parallel to line segment KM. Again, we're always starting our proofs off with that given information. The reason that we can write that in statement number 1 is that because we were given that in the original problem. So I'm going to go ahead. Remember, we mark things parallel with little arrows. So this is parallel to this, and then this is parallel to this. So for one of them, we use one little arrow, and the other ones we're going to use 2, just because they're not all parallel to each other. So if we were to talk, well, that's not very good at drawing lines. But. So if we were to focus on just these lines right here. Oh, I can't draw. There we go. So just those 3 that I've extended, and we're going to ignore the other ones for a second. This angle and this angle, again, we're ignoring this line and ignoring this line. If I just look at those 3 lines, the angles that I just marked congruent are alternate because they're on opposite sides of the transversal, and they're interior because they're in between the 2 parallel lines. So they're alternate interior angles, and we know that alternate interior angles are always congruent. So those 2 angles are congruent. We justify that by alternate interior angles. We can do the exact same thing with this angle and this angle. Those are also alternate interior angles. Remember, alternate interior angles are always congruent. And then line 4, line segment KL is congruent to line segment KL. Again, my favorite because everything's congruent to itself by the reflexive property. If I go ahead and mark that in my diagram, that's in the middle, notice that line segment is shared by both triangles, and it's included between the 2 angles that we just proved congruent. So it is the included side, which means we've proved this congruent by angle, side, angle. I want you to start this one. You have 2 given pieces of information, so those are going to go on lines 1 and 2. So start by copying down that angle BAC is congruent to angle DEC, and then mark that in your diagram. And then for line 2, you're going to have C as the midpoint of AE, and your reason, again, is going to be given because you are given that information to start the problem. All right, so for line 1, you wrote the angle BAC is congruent to angle DEC. So in my diagram, I want to go ahead and mark those 2 congruent to each other, just like that. For line number 2, we wrote that C is the midpoint of AE. Keep in mind, a midpoint just creates 2 equal segments. If C is the midpoint of this line segment, I know that the 2 pieces it creates, AC and CE, have to also be congruent. So I know that AC, line segment AC, is congruent to line segment EC by the definition of a midpoint. So now we've proven one angle and one side. We've got to prove something else. So when I look at these, I see we have an intersection here at the middle of point C. Anytime there's an intersection, there's 2 pairs of vertical angles. So this angle has to be congruent to this angle because they're vertical angles. So I'm going to say that angle BCA is congruent to angle DCE. And again, I'm double checking. I have 2 angles and the included side. So I can prove these 2 triangles congruent. So triangle ABC is congruent to triangle EDC. And my justification, whoops, I skipped. Oh, vertical. And my justification for those 2 triangles being congruent is angle, side, angle. Next, we're going to learn about angle, side. So for this one, we need two angles, but for angle side, the side does not have to be included. So the side's not included, you're gonna find two angles in a non-included side. And then we can prove the two triangles congruent by AAS, or angle side. So what that looks like, here we have a diagram. We know in our diagram that angle A is congruent to angle D, they're marked congruent. Angle B is congruent to angle E, again, they're already marked congruent for us. And then side BC is congruent to side EF, again, that's the non-included side, or one of the non-included sides. And therefore, we know that these two triangles are congruent. So we're going to work through a few proofs with this. I think 3. So we're given information that YZ bisects angle WYX. And then we're given that angle YWZ is congruent to angle YXZ. So we're going to start with those two lines, or two sets of information on the first two lines, the reason behind them that they're given to us. So we're given that YZ bisects So with that information, the only thing you can really write in your diagram is that angle YWZ is congruent to angle YXZ. So this angle here is congruent to this angle here. The information that YZ bisects the angle WYX. So it's telling me that this angle here is being bisected by this line. If that angle is being bisected, it's creating two congruent angles, in this case, these two angles here. So I know that since that angle is being bisected, that angle WYZ has to be congruent to angle XYZ. Again, we know that because the information in line 1 told me that YZ is bisecting that angle up there. So now we've got two angles. And we need to prove a side. What side can we prove congruent in both triangles? So we can always prove the same side congruent to itself. So if you look at our diagram, YZ is shared in both triangles. This side right here is shared in both, which means it has to be the same in both triangles. So YZ is congruent to YZ by the reflexive property. So now when I look at my two triangles, I've proven two pairs of congruent angles, one pair of congruent sides. The side is not included, so I can prove them by AAS because the side's not included. So now I know that triangle WYZ is congruent to triangle XY. All right, next one. We're given that angle ABC is congruent to angle CED. So that's going to go on our first line. And we're told that AB is parallel to CE. So let's see, this is parallel to this. And then we're also told that C is the midpoint of AD. So first three lines all given information from the original problem. So we've marked some information in our diagram from those three things. We didn't mark anything when we wrote statement number 3 that C is the midpoint of AD. Remember, a midpoint cuts your line segment into 2 equal pieces. So from C being the midpoint of AD, we know that AC has to be congruent to CD by the definition of a midpoint. And I'm going to mark that in my diagram. So this right here is congruent to this right here. We also know that line segment AB is parallel to line segment CE. So this segment is parallel to this segment. And I want to talk about this transversal here. So those 3 black lines, we're going to ignore all the other lines for the time being. And we're just going to talk about these 2. So when I look at these 2 lines, again, I'm ignoring this line and I'm ignoring this line for the time being. Those 2 parallel lines are being cut by this transversal here, creating 2 corresponding angles. Angle BAC and angle ECD are corresponding. They're both at the top right of the intersections of that transversal, so they're therefore congruent to each other. So I can say that angle BAC is congruent to angle ECD because they're corresponding. So then going back to my triangles, we've now proven 2 angles in one side. Since that side is not included, we're going to use angle side to show that triangle ABC is congruent to triangle CED. Moving on to the next one, we're given two parallel lines. So LG is parallel to JM, and then we're also told that H is the midpoint of LM. So those are going to be our first two lines. There's really not anything you can draw on your diagram unless you want to mark that these two are parallel to each other. I would start off with line 2. If we're given a midpoint, if H is the midpoint of LM, it must be splitting that line segment in half. So I know that LH is congruent to MH. So now we're going to focus on our parallel lines. So I've kind of edited our picture to make it easier to see. We have two parallel lines being cut by a transversal. This angle right here and this angle right here, both of them are inside that triangle. What kind of angles are these? So angle GLH is congruent to angle JMH, and my justification would be that they are alternate interior angles. I forgot to write on line 3, we prove those congruent by the definition of a midpoint. So now if we go back to our parallel lines, and we think about this transversal, and we ignore this line here for a minute, both triangles include this angle here. So angle G and angle J. They are also alternate interior angles. So angle G and angle J are congruent by alternate interior angles. So looking back to my diagram, we've proven two pairs of angles, one pair of sides congruent. The side is not included. So my justification for these two triangles being congruent is going to be AAS because the side's not included. And then my congruency statement is just going to be triangle LGH. H is congruent to triangle MJH. And again, you can just copy that down from right here. The last triangle congruence we're going to learn is probably the one that stands out the most. So the right triangle congruence is called HL. HL stands for hypotenuse leg. So if you have a hypotenuse, the longest side of your triangle, and one leg of a right triangle, keyword, it must be a right triangle, congruent to the hypotenuse and the leg of another right triangle, then the two triangles have to be congruent. So if we look at this diagram, we have if the hypotenuses are congruent. So my hypotenuse on the left triangle is BC. It's congruent to the hypotenuse on the right triangle, EF. And then the leg is just one of the other two sides. So BA congruent to ED. Then your two triangles must be congruent to one another. So triangle ABC would be congruent to triangle DEF. And then keep in mind your hypotenuse is always the side opposite of your right angle, and a leg is a side adjacent touching the right angle. So looking at this next question, we're given that we have two right triangles. So for reason number one, we're going to write given. That was given to us. It's actually already marked in our diagram. The second thing we were given is that ML is congruent to MN. So this is congruent to this, given. And those are actually both hypotenuse. So they're opposite of the right angles. So that's our hypotenuse. We need to prove that one of the legs is congruent to one of the legs on the other one. In this case, we're going to use that shared side of MP being congruent to MP by the reflexive property. So that shared side there in the middle is congruent to itself by the reflexive property. And at this point, we can prove these two triangles congruent because we have a right triangle. We've proven their hypotenuses are congruent in one of their sides. So our justification, we're just going to write HL. For this next question, we're given two right triangles. We're given that ML is congruent to MN. Those are going to be our first two lines. No. I lied. Skip this problem. The instructions don't match our diagram. So we were given that triangle LMP. We don't have triangle LMP. So I goofed. We can't do this one. But if we were given that they're right triangles and one of the sides were congruent, keep in mind that I would assume that you would have to show that these are vertical angles to prove they're congruent. I don't really know what the actual instructions were, but that's my fault. I'm sorry. So some warnings. There is no such thing as an ASS postulate. You cannot prove triangles congruent by ASS. That means if you prove one angle and two sides, you cannot prove them congruent. I can give you all the same angle and two sides, and you can draw two different triangles. So that's not a valid justification, and neither is AAA. There's no such thing as an angle postulate. I could have two triangles with the exact same angle measures, but they could be different sizes. So those are not valid postulates that we can use. Here are the valid postulates we can use. So we learned about side, angle yesterday. Today we've thrown in side, angle, side, and HL. Keep in mind the bottom two are not possible. So we're going to name that postulate when possible. We're going to start with the pair at the top left. I'm telling you, you have two congruent pairs of sides and one congruent pair of angles. What do you think it is? SSS, ASA, SAS, AAS, or HL? So if you have two sides and one angle, the angles in the middle or that's included between the two sides, it's going to be SAS. For the one in the top right, you have two angles and the included side. That one's ASA, angle, side, angle. You have two angles and the included side, ASA. When I look at the one at the bottom left, I have an angle and two sides, but the angle is not included. So technically this one would be ASS, which is not a valid congruency statement. So this one's not possible. And then the last one, we have all three sides congruent to all three sides. That is SSS, side, side, side. On the next slide, we were given three angles. Can you prove triangles congruent by all three angles? No. So AAA is not a congruency statement. So it's not possible. For the top right, we have two angles in the included side. That is ASA, angle, side, angle. For the one in the bottom left, we have two sides in the included angle. Side, angle, side, SAS. For the bottom right one, we have two sides and an angle. The angle is not included, so it would be ASS, which is not possible. Yes, they look the same, but you cannot judge based off of the diagram's looks alone. You have to be able to follow one of the postulates. A few more. So looking at this diagram, we're going to have to make some assumptions. So looking at the one on the top left, they share this side, which means it has to be congruent to itself. So I can add information to that diagram, and now I have two pairs of sides and an included angle, which is side, angle, side. For the one in the top right, again, we're going to have to add information in. We know that these two triangles have vertical angles right here and right here, which means they have to be congruent to each other. So I know that I have vertical angles that are congruent, so now I have two pairs of sides and the included angle, so side angle, side again. The next one's very similar. We have two sides marked congruent. We have vertical angles here and here, so side angle, side. And then the last one, we have a shared side, which we can mark congruent. We have two sides and an angle, but the angle is not included, so this is not possible. Again, that would form ASS, and which is not a valid congruency statement. All right, for the last one, we're going to list any additional information needed that would enable us to apply the specified congruence postulate. So if I was trying to prove these two triangles congruent by angle, side, angle, I would have to show that I have another angle that's congruent. So we were given a side and we were given an angle. If I want angle, side, angle, I have to pick the angle that would include the side that we were given. So if I wanted to include that, I would have to show that this angle is congruent to this angle. That would give me my angle, then my side, then my angle. So I would have to know that angle B is congruent to angle D. That's the information I would need to show that these two are congruent by angle, side, angle. For side, angle, side, we have a side and we have an angle, but I need another side. I have two options. I can pick this side or I can pick this side. It matters because you want the one side that would include the angle. So I have to pick AC because that would include angle C. So side AC would have to be congruent to side FE. And then for angle, side, we need to know another angle, but this time we don't want to include the side. So that would be angle A congruent to angle F. Because if I mark this and this, that would be my non-included side.